According to the Massachusetts Electrical Code, specifically 527 CMR 12.5b, a disconnect is indeed required for 200 amp service entrance. This requirement stands regardless of the physical distance between the service entrance and the main electrical panel. The code mandates that every service, feeder, and branch circuit must have a readily accessible means of disconnecting the circuit conductors. This disconnecting means must be located at the point of origin from all sources of supply to that circuit, and it needs to be within sight of the equipment it serves. For services, the code explicitly states that each service entrance shall be provided with a service disconnecting means that has adequate capacity for the service. In your specific scenario, even though the service entrance to the panel is approximately 8 feet, the Massachusetts Electrical Code necessitates the installation of a disconnect. This is to ensure safety and compliance with electrical regulations. Let's delve deeper into why this requirement exists and what it entails. The primary purpose of a service disconnect is to provide a safe and convenient way to de-energize the entire electrical system of a building or a specific portion of it. This is crucial for several reasons. Firstly, it allows electricians and other qualified personnel to safely perform maintenance, repairs, or upgrades to the electrical system without the risk of electric shock. Secondly, it provides a means to quickly shut down the power in the event of an emergency, such as a fire or electrical fault. Thirdly, it facilitates the isolation of the electrical system for inspection or testing purposes. The readily accessible requirement means that the disconnect must be easily reached and operated without the need to climb over obstacles, move heavy objects, or use special tools. It should be located in a place where anyone can quickly find and use it in an emergency. The insight of the equipment served requirement ensures that the person operating the disconnect can clearly see the equipment that is being energized. This helps to prevent accidental energization of the equipment while someone is working on it. The adequate capacity requirement means that the disconnect must be able to safely handle the maximum current that the service is designed to carry. In the case of a 200 amp service, the disconnect must be rated for at least 200 amps. When selecting a service disconnect, it is important to consider several factors. Firstly, the voltage rating of the disconnect must be compatible with the voltage of the service. Secondly, the ampere rating of the disconnect must be equal to or greater than the ampere rating of the service. Thirdly, the disconnect must be suitable for the environment in which it will be installed. For example, if the disconnect will be located outdoors, it must be rated for outdoor use. There are several different types of service disconnects available, including circuit breakers, fuse disconnect switches, and knife switches. Circuit breakers are the most common type of service disconnect. They are reliable, easy to operate, and provide overcurrent protection for the service. Fuse disconnect switches are similar to circuit breakers, but they use fuses instead of circuit breakers to provide overcurrent protection. Knife switches are the simplest type of service disconnect. They consist of a blade that is inserted into or removed from a set of contacts to open or close the circuit. They are typically used for low voltage, low current applications. The installation of a service disconnect must be performed by a qualified electrician in accordance with all applicable electrical codes and regulations. The electrician will ensure that the disconnect is properly sized, installed, and grounded. The electrician will also verify that the disconnect is readily accessible and within sight of the equipment served. In summary, the Massachusetts Electrical Code requires a disconnect for a 200 amp service entrance regardless of the distance from the panel. This requirement is in place to ensure safety and compliance with electrical regulations. The disconnect must be readily accessible within sight of the equipment served and of adequate capacity for the service. The installation of a service disconnect must be performed by a qualified electrician. It is imperative to consult the specific edition of the Massachusetts Electrical Code that is currently in effect in the area where the installation will take place. Electrical codes are subject to change and updates, and it's essential to adhere to the most current regulations to ensure safety and compliance. Furthermore, local jurisdictions may have additional requirements or interpretations of the code, so it's advisable to check with a local electrical inspector or building department to confirm any specific local requirements. When planning the installation, consider the location of the disconnect carefully. It should be placed in a location where it is easily accessible to both residents and emergency personnel such as firefighters or electricians. Avoid placing it behind locked doors, in areas that are difficult to reach, or in locations where it could be obstructed by furniture or other objects. Ensure that the disconnect is properly labeled with clear and concise instructions on how to operate it. This will help anyone who needs to use it in an emergency to quickly and easily shut off the power. Regularly inspect the service disconnect to ensure that it is in good working condition. Check for any signs of damage such as cracks, corrosion, or loose connections. If you notice any problems, contact a qualified electrician to have them repaired. Never attempt to repair a service disconnect yourself, as this can be dangerous. When working on or near electrical equipment, always take appropriate safety precautions. Wear insulated gloves and eye protection, and use tools that are rated for electrical work. Never work on electrical equipment while it is energized. Always turn off the power at the service disconnect before starting any work. Grounding is another crucial aspect of electrical safety. The service disconnect must be properly grounded to provide a path for fault current to flow back to the source, which helps to prevent electric shock and fire hazards. The grounding system should be inspected regularly to ensure that it is in good working condition. Overcurrent protection is another important safety feature. The service disconnect should be equipped with overcurrent protection devices, such as circuit breakers or fuses, to protect the electrical system from damage caused by excessive current flow. These devices should be properly sized to match the ampacity of the conductors they are protecting. Surge protection is also recommended to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors can help to absorb these surges and prevent them from reaching sensitive equipment. Arc fault circuit interrupters, also known as FSIs, are a type of circuit breaker that is designed to detect arc faults, which are a common cause of electrical fires. FSIs can help to prevent fires by quickly shutting off the power when an arc fault is detected. Ground fault circuit interrupters, also known as GFCIs, are another type of circuit breaker that is designed to protect people from electric shock. GFCIs can detect ground faults, which occur when electricity flows through an unintended path to ground. GFCIs can quickly shut off the power when a ground fault is detected, which can prevent serious injury or death. In addition to the requirements of the Massachusetts Electrical Code, there may be other applicable codes and regulations that must be followed. For example, the National Electrical Code, also known as NEC, provides comprehensive guidelines for electrical installations. The NEC is not a law in itself, but it is often adopted by state and local governments as part of their electrical codes. It's important to familiarize yourself with all applicable codes and regulations before starting any electrical work. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician. A qualified electrician has the training, experience, and knowledge to safely and properly install electrical equipment. They can also ensure that the installation complies with all applicable codes and regulations. When hiring an electrician, be sure to check their credentials and references. Make sure they are licensed and insured, and that they have a good reputation. Get a written estimate of the cost of the work before starting the project. The estimate should include a detailed breakdown of the labor and materials costs. Don't be afraid to ask questions and get clarification on any aspect of the project. A good electrician will be happy to explain the work that needs to be done and answer any questions you may have. Finally, remember that electrical safety is everyone's responsibility. By following these guidelines, you can help to ensure that your electrical system is safe and reliable.